Hello all, welcome back. So today we are looking to solve one of the problems that I've been facing. So what happened is we are in the middle of this COVID pandemic and all of us are having to work from home. And much of the development work that I do, it resulted in my internet download limit running out. It's just halfway through the month and I've exhausted about 400 GB of my internet download limit. And after that, the connection gets throttled, so even simple things actually don't do so very well. So, for example, streaming and even things like connecting to meetings over Zoom or over Hangouts. That doesn't seem to work so well once the throttling starts. So I decided to solve this problem by creating an online workspace where I could do my development. So I don't continue to build my images on my local system, but instead I could do this on the cloud. So that's what I'm attempting to solve today. And so uh, what I'd like to do for this is I'd like to create a GKE cluster on the cloud and have Visual Studio Code deployed there and connect to VS Code through the browser. Um, and of course, that's the first part of the problem that I'm going to solve. But the second more interesting problem is to enable Docker image builds. Now, if you try and understand what this is, we are trying to work with Docker. We are trying to build images with Docker inside of a Kubernetes pod. So that's the second part of the problem that you're going to solve. So let's start with this. The first thing that I'm going to do is dedicate a folder where all of my files are kept. So I'll keep that in workspaces, cloud dev workspace. Of course, this doesn't exist. So this is the empty directory where I'll create all of my files. So the first thing that I'd like to do is make sure that cloud code is available. So what cloud code allows us to do is this is a tool, SDK tool, which is provided by Google. It works in Visual Studio Code and it works in IntelliJ. Uh, and what this allows us to do is connect to GKE and any other cloud providers to work with Kubernetes. So the first thing that I'm going to do is create a Google Kubernetes cluster. So of course this requires a lot of information which I don't have handy right now. So gcloud tool could help me get this information. This is the default project. And in step 2, we can select what type of cluster this is, zone or region. I'm selecting zone so that it creates only one node. If I select regions, then it will create one node in every zone. So if the region has 3 zones, then it will create 3 nodes. I just want one zone. And I'm going to select Asia South 1C, which is in Mumbai. And the cluster name is going to be dev cluster with one node. N1 standard 2 is what I'd like to select, which is 2 vCPUs and 7.5 GB of RAM. And I'm not going to enable Istio or Crowd Run for Anthos or any of this. Just a simple plain vanilla Kubernetes cluster would suffice. Allow full access to all cloud APIs, because remember, I might want to run my gcloud CLI or use the Google Cloud APIs while doing development. So I want complete access to the cloud APIs, and I'm creating a cluster. So this is a command that it's executing. What I can do is copy this, put it in a file. So I'll just wait for the cluster to be deployed. In the meantime, let me update you with what plans I have for this project. So first of all, there's going to be a setup.sh script. There's also going to be a teardown.sh script. So setup.sh script is where we'll be calling the other individual steps of the setup process. So in this case, the first step is to create cluster, and teardown is where we are going to stop the cluster. So the cluster was created successfully and added the default kubeconfig file. Now remember, when we create the cluster using the CLI tool or using this command or the shell script, that it does not really set the kubeconfig to this. So what we are going to do is we are going to figure out what the command is. So there's a place in Google Cloud Platform where it shows us this command. All we have to do is open this Kubernetes engine, list the clusters, and there's a connect key here which gives us this command. So I'll just copy this command and create another script here, call it configure kubectl.sh, and that's it. So, and in the setup script, I'm going to call configure kubectl.sh, and that's it. But there seems to be some problem. I don't know why. Click on the cluster name for details. Okay, I did that. So it says that it doesn't have enough resources to fulfill my request. It can happen from time to time. Usually I tend to get these errors on a Sunday. Today is Sunday, as you can see. So what we're going to do is modify this a little bit. So there are also other concerns which I'd like to address here. Primarily the one regarding the cost. So I'd like to make this preemptible. So what would happen with preemptible instances is the excess capacity that's sitting idle in Google's data center is then given out to you at a reduced price. So usually it gives it to you at about 20% of the actual price. So preemptible is going to be is going to save a lot of money for me. So I'm going to make it preemptible. I'm also concerned a bit about the about which version of Kubernetes it's using. So it did not ask me the question when I'm setting it up with Cloud Code. So let me try creating a cluster over here. Of course, I'm not going to create it per se, but I'm just going to get the Kubernetes version out of here. So if you see, here is the version 1.15.11-gk-5. Right, so let's see the command line for this, and where is the Kubernetes version? Here. What else? Now remember, different people might prefer different configurations over here. So also things like hard coding of this project may not always be a good thing to do. People should be able to customize this, because I'm expecting people other than me, my colleagues, or even you to use this script. So the way I'm going to do this is create a env.sh script which is going to export all of these parameters here, all the configurable parameters here. So the first thing is which project, which region, uh, which version do we want to use in Kubernetes. So let's just configure these first. So it's not a region actually, it's a zone. Cluster name, of course. The name of the project. Kubernetes version. Where did it go? I remember pasting it. Oh, I'm pasting it in the wrong place, so I'm just going to move this to create cluster. I don't like this equals so much, so I'll just remove it. No particular reason, but I'm used to typing commands without equals, that's it. So that I believe is all of it. Also in the teardown, we need to configure the cluster name. Right, now just let's try with another region, Asia South 1B, and this time instead of using cloud code we're going to run the shell script. So the way to run it is to first source the env.sh so that all the environment variables are set, so you can verify that with the echo command. Right, that seems to work. Now we are going to run setup.sh. Okay, remember to make all of these executable. Okay, there seems to be some problem here. Machine type is expected. Okay, I haven't configured the machine type anywhere. N1 standard 2 is the machine type I'd like to set. There is a machine type, but I don't think I've set it in env. Yeah. So now if I were to source it, it should work correct. Yeah, there you go. So let's start it now again. And it seems to be creating the cluster. So let's hope there is enough capacity for us to create this cluster here. Okay, so let it take its own sweet time. Until then, let me explain to you something else. Okay, so what's the big idea? After deploying the Kubernetes cluster, what are we going to do? So this is where one of the projects is going to come very useful for me, and this is cdr/code server. So cdr/code server is um, one of the projects which is created by this Codacom team, and this allows us to run Visual Studio Code in the browser anywhere. So that's their idea. So here you can see the demonstration of this running anywhere. Now I could show you how this looks like on my dev environment before even I start deploying the cluster, but then that defeats the purpose, because I'm trying to avoid downloading any further Docker images, and by just demonstrating this to you, I have to download the code server Docker image and show it to you, which I do not want to do. Instead, I'm directly going to deploy this onto the Kubernetes cluster and then going to show you a demonstration of this. In the meantime, let me check if this cluster is created. Not yet. Okay. Okay then, let me start creating the Helm chart for this. So why do we need a Helm chart? Why can't we directly write the YAML files? I could do that, but remember, I'd also like my team or anybody working with me, my colleagues, anybody, to use the same environment. So if you were to write Kubernetes manifest files, just the YAML files, and deploy it over there, you could deploy only for one particular person. So you could deploy just for me. But if I try to deploy the same manifest files for another person, then it wouldn't work out. Now, one of the simpler ways over there is to create a namespace for each of us separately. So if so I deploy it in my namespace, somebody else deploys it in their own namespaces. That way there is no collision of the names of the Kubernetes resources. But there's also another elegant way to do this, which is using Helm chart. So in Helm chart, we templatize our manifest files, so we can configure it so that each of the resource gets a unique name, and we basically deploy the same Helm chart in multiple releases. So it becomes easy for us to create newer releases and also delete or uninstall these releases. So that's the benefit of using Helm. So in case you're not familiar with Helm, don't worry, it's basically manifest files with a little bit of templating capabilities. Right, so now you can see that there is some problem here. This problem is not with the cluster creation, but rather with my configure kubectl command. As you can see here, I have not parameterized it, so let me do that. Here is the cluster name. Here is a zone. And here is a project. So now if I were to call configure kubectl, the command works correctly. Okay. Now we can verify whether kubectl is configured correctly or not by checking the nodes on the cluster. So kubectl get nodes, says that there is one node running over here. Kubectl get all, show that this one service running. This is the default Kubernetes service, which is fine. So next thing I'm going to do is create a Helm chart. So Helm create dot. It's going to initialize the current directory with the default files. And the first thing I'm going to change is the chart.yaml, which requires a name. So this is the Cloud Dev Workspace. So the versions, I'm just going to keep this as it is. I'm going to use a version which for app version, which is code server version. So let's look at what versions are available on Docker Hub. .1.1. So that's what I've typed here. That should be fine. And next thing is the template. So I'm going to delete all of these. Yeah, I'm going to delete basically all of these. And then create a new deployment.yaml. Now I can generate a deployment YAML. So there is a snippet already configured. So I could do this, and the snippet is already configured here. So how this basically works is because of an extension that I've installed. This is the Kubernetes extension for Visual Studio Code. So this has all of the snippets and allows me to work with Helm and provide Helm snippets, which are very convenient. So I'm not going to touch any of these things, but what I am going to change is the name of the image. So here I'm going to say that the image name is coder.com/code server : and then comes a chart version. And then comes certain other configurations that we can do. Now remember, this app has, so this chart has certain values that we can set. So let me first clean this. I'm not worried about replica count because there's always going to be one replica of code server or one replica of Docker host. We don't want multiple replicas of them being present. That's going to confuse, since the application which we are building is stateful, which is when we are writing code, that code would be present inside a pod. If there are two versions of the pod, if there are two replicas of the pod, and only one of the pod is going to have the files that we are changing. So if we were to connect to another pod, then our code is not going to be there. That's why we would want the replica count to always be 1. We are not making this configurable, so this is something which can be removed. The next thing is there's going to be an image. Now remember, there are two services which we are planning to run. One is a code server. So for the code server, the image is going to be code server, code-server : 3.1.1. Pull policy is not present. So the tag can be, this is the tag actually. This is a configuration for the code server. For Git, we will come a little later. We don't need image pull secrets because we are using public images. No name override, full name override, none of this. Service account, yes, we require a service. Do we require a service account? I don't think so. I'm going to remove this. Pod annotations, pod security context is something we need, but we are going to hard code it because if you were to change this, then it wouldn't work. So I'm going to remove this. Security context. Also, I'm going to remove service is something which we are going to need. So for the service, the type is going to be load balancer, so that we get a public IP for our code server, right? And the port, we are going to use a non-standard port, not 80, not 8080, because since we are doing development, we might want to run something on port 80 or 8080 or any of those standard ports, right? So I'm going to use something random, 4752, 4751. Okay, and this, yeah, that should be it. Ingress, we are not configuring it now, but at a later point I do want to configure it, because the type load balancer is an expensive way to get public IP addresses. Instead, we could use something like an Nginx ingress controller and configure an ingress there. So not today, but some other time. The resource limits, yes, this is something which we need. So code server will have its own resource limit. So I'm going to move all of this under code server. No auto scaling needs to be configured. Do we need a node selector? Not really. No tolerations, no affinity. So this is our short and simple values. We will be changing this over the course through this video several times, but this, I believe, is good enough to start with. Now remember, we had typed the image name over there for the code server. So now we have to use the image name as codeserver.image.repository. So let's do that. Go to our deployment. values.codeserver.image.repository colon and the image tag, which is going to be image.tag. So let me put all of this in quotes. Image pull policy is going to be values.codeserver.image.pull policy. So for the ports, I'm going to use service port, and resource limits are over here. So this is not going to be values.resources, it's values.codeserver.resources. Yeah, so this is going to be my deployment.yaml. Now in addition to this deployment, I am going to require a service. I'm again going to use the snippet, which is available with the Kubernetes extension. I'll give it a name. The name is again going to be the same name which is present here. label is this chart which is the same here. Now the important part here is a selector app. If you look at this template spec, we have to understand what is the uh, label which is being put here. So if you see there's a metadata label app dollar full name. So dollar full name is a label here. We're going to set same thing here as well. So that this service is going to select the pods which has this label and load balance all the requests to all of these pods. And since the replica count is only going to be 1, it's always going to forward it to that one pod. And the type should be values dot code server dot service dot type code server dot service dot type. Okay, now the other thing is we have set this port number for our application. We have to make sure that this port number is being used first of all at the pod level. So this I know that the code server image is going to use port 8080 by default. Now I have to pass a few arguments to make sure that it uses the port that I wanted it to use. Right? So this will make sure that the code server is actually using this port and not any of the standard ports. And now when we are writing the service, we should also configure the port here. Values code server service dot port. So looks like it's fine. Now let's try deploying this. kubectl apply -f dot. Not exactly. Since we are deploying a Helm chart, Helm install code server dot. Let's hope this works. Seems to be some problem here. Values code server service type nil. In service.yaml. Code server service type looks okay to me. Values.service.main. Okay, where am I using this? Service.yaml line 13. The name, I don't need to provide a name, but let's just say this is going to be code server. Deployment.yaml line 19. This is where the error is, and what is the error? Nil pointer. Evaluating interface dot image. Values code server image tag is null, it says. That looks fine to me. This is deployment.yaml, line 1968. Okay, there's no R here. That's a typo that I made. Let's see if it works now. It says it is deployed. Let's see if we are able to get all of these or not. Okay, so the service is created, the deployment is created, it's still not ready yet. So let's just wait. The service would give us an external IP address and the deployment would say it is ready. There seems to be an image full backoff, seems to be something wrong with the image name. So let's troubleshoot it. What is the image name? Okay, code server. It's supposed to be codercom/code server. So let us correct that. Delete, uninstall this release and install it again. So it says the status is running now and it is ready as well. So the external IP has not yet come, or in fact, if you look, the service got deleted. And the reason for that is because this happens whenever there's a race condition. So I deleted the previous Helm chart very quickly and then I deployed the new one very quickly. So Kubernetes GKE, the Google's Kubernetes engine, it's going to delete an actual load balancer when we delete the service, which took a little bit of time. And once the load balancer got deleted, it deleted the service itself. But that happened after we created a new release from Helm. Hence, our service is now gone. So this happens during race conditions. So remember, whenever we uninstall something, we just have to wait for some time until all the resources are cleared. So what I'm going to do now is uninstall code server. Just wait for everything to get cleared. There's a pod that still is terminating. It's gone now. Now we're going to say helm install code server dot. So the pod is running. We're just waiting for this IP address to come along. Right, so here's the IP address. And all we have to do is connect to this IP address and the port 4751. Okay, so this is asking me for password. I didn't set the password, so I have to get it from the logs. Here it is. And here is our VS Code editor. Right, so we set up our dev environment. Of course, there's a problem with the password. Let's fix that first. We have to be able to set the password ourselves. So let me set that password in this fashion and modify the deployment and pass an environment variable here. Let's wait for the service to get clear. In the meantime, we are also going to set the resource limits here. Or in fact, do I really need to set it? Since it's a development cluster, I really don't need to worry about setting any resource limits. But then on second thoughts, if I try to deploy this for multiple people on the same cluster, I need some sort of mechanism for planning and also for Kubernetes to schedule this intelligently. So I have to set some resource limits. Let's do that. So I'm going to go to values, set the resources limits here, uncomment these lines, and set the CPU to, let's say, I have two CPUs, so 1.2, 1.5 CPU hopefully should be schedulable, and memory about, this has got 7.5 GB of RAM, isn't it? 7.5 GB. So let me try scheduling 5 GB of RAM. I'm going to have the same for request as well, and then wait for the service to be removed. It's removed, and then release it. Oh, we have to wait for this external IP to be generated, and then we can test it. But even before that, let's see if this pod has any issue scheduling. This is saying pending, so looks like it is having some issues. One insufficient CPU, one insufficient memory. So neither the memory nor the CPU is sufficient here. So I'm going to use 4.5 GB of RAM and say 1.2. CPU. So what I'm going to do, since I'm only going to check if it's getting scheduled or not, for the time being I'll comment out the service. And it is running, so it looks like the resources are sufficient. So let me uninstall it. And install it again, this time with the service. And wait for it to get an IP address. Okay, so here is the IP address. Looks like my password has taken effect, so that's good. Okay, and things seem to be working fine. Now if you look at this says that there's a problem with accessing code server over insecure domain. So things like web views, clipboard, and other functionality will not work as expected. So we have to configure SSL for this, but we'll do that some other time. For the time being, I'm just happy with this working on the cluster. Now the next thing that we can do is we can figure out how to run Docker, how to provide access to Docker. Now there's a small trick over here to do that, and to do that we have to understand the Docker official image. So there's a special type of image which is available. With DIND. So DIND basically stands for Docker in Docker. So this runs a Docker daemon inside of a container. Of course, there are certain limitations with this. So let's look at what those limitations are. Okay, so this is how we can run it. This has to be run as privileged. And it generates all of these files, the certificate files. So we have to make sure that the client certificates are available on the client side. So let's first get this to work. So what we are going to do is we are going to make sure that this runs in another container but within the same pod. So Docker host running in another container in the same pod basically is accessible with it. It uses the same network as a pod. So the code server should be able to connect to this Docker service at localhost 2376. Okay, so that's the first thing that we are going to do. So we're going to go to the deployment YAML, and there is one container already present here. We're going to create another container. Whose name is going to be DIND. requires an image which we are going to configure here. I don't want to pass any arguments to it. Environment variables. Of course, we have to we have to configure the search directory using either an environment variable or arc. So let's see what is required here. So it requires Docker search path. Docker TLS search dir is what we have to set. We'll keep it in the search directory. Any port we want to expose. Honestly, since it's working in the same network, we don't want to expose it outside of the pod. Let this be within the pod. No liveness probe or readiness probe I'm configuring, but I want to configure volumes here. Let's see how to configure volumes. Mtdir is what I want to configure. So volumes name mtdir is the first thing. We'll have to configure volume mount here. Mount path and name. So I'm going to only mount the client's certificate here, because if you look at this documentation, then three directories are created: CA, server, and client. So I just want to share the client certs to the client. So this is what I'm going to set: certs/clients. And the same volume should also be available in here. There is a mount path. I forgot to give the name. Okay, so that is that. And Yeah, so I think the certs would be generated, it would be set over here. Now in addition to this, we have to set a few more environment variables on the client side. Okay, so I tried these instructions before, they didn't seem to work correctly. So what I'm going to do is I'm going to look at the Docker documentation. And set several things. First is the Docker host I'm going to set on the code server container. I believe this is running on port 2376. Yeah. So Docker TLS is what we need to set. TLS and TLS verify. And then finally certs. Docker cert path. Slash certs. The slash certs is where Docker certs is being mounted. Here it's being mounted in cert slash clients. So it only has a client certificate which is being mounted at certs in this container. Right? So looks like everything is configured correctly, but let's make sure. Okay, now I do know that the services are the problem. I have to wait for the services to get created, but first let me verify that the pod starts up correctly. So I'm just going to install this first. And now you can see that there are two containers in this pod and it says it is pending. Why does it say that? It says that there is insufficient CPU. Now what we have to make sure is that configure resources over here as well. I'm going to give 0.2 CPU here and 1 CPU here. It says in my deployment spec template spec unknown field resources. Oh, of course, this shouldn't come here, it should come before volumes. It looks like the containers have started. Now let's look at the logs and ensure that the pod that the certs are generated. Okay, so it says app armor detection and privileged mode might break. Oh, of course, we forgot to run this as privileged. So let's first do that. We have to wait for this to terminate, only then the resources should uh, become available. Yeah. It is taking quite some time. Let's see what's happening. Oh, it started. Okay, so as you can see, it looks like the server has started, Docker server has started, and it's listening on port 2376. Things seem to look fine, but let's make sure that the app server, the code server is also configured correctly. Okay, remember there's a problem with the service, so we are going to uninstall this code server. Wait till the pod gets deleted. Yeah, and now install. So here is the external IP. Looks like it's having some problem scheduling this. Let's figure out what it is. Okay, it's creating now. One container is running, both of them are running. So let's first check if the environment variables are set correctly. Docker host is set. These two are set. Now the Docker third part. But the search directory is empty. So this is a problem. We don't want the search directory to be empty. This is probably happening because of this. So let's get into the Docker and see whether the path is correct or not. So if you see here, clients is not the correct path. Client is a correct path because clients is empty. So this volume mount should be search/client. Let's uninstall this. Wait until all resources are removed, including the pod and the service. Yeah, and install it again. The pods are ready. We can actually check for the environment variables directly from kubectl. So now you can see that the certs are available. Let's just wait to get a public IP. Yeah, we have gotten that. 4751 is what we need to connect to. Here it is. So all environment variables are set correctly now, and also certs has all of these uh, certificate files and all, right? So the next thing is we have to install Docker and make sure it works correctly. and you can see that the Docker commands are now working, right? Let's also try with Docker Compose. The first thing that I'll try is create a code server, create Docker compose.yaml file. I'm going to have the instructions to install Docker. So the first thing that I did is run. Of course, space doesn't work because we are not working with a secure connection. So okay, so there seems to be something wrong. Maybe my pod crashed. No, it's still running. Okay, it's fine. So it still says it's connecting. Is my internet working? Yes, it is. So what just happened to this? Yeah, so looks like something went wrong and it is recreating my container. So what really happened? Let's find out. Okay, something to do with the network. On the cluster, maybe I have been taking up too many resources here, because of which there's some sort of problem. Okay, let me try recreating this again. So I'll just kill the pod. And it's going to create one again. Okay. Let's try connecting now. Yes, so here we are. So all that we did to install Docker would now have been gone because it recreated the pod. So the changes would not persist. So that's one of the reasons why I was trying to create a Docker file which contained uh, the which already had Docker in it. So again, I have to go through the steps. So let me do it in parallel. So just to be on the safer side, I'm going to create these files on my local instance. So perhaps the most important part is the Docker file and the Docker compose file. and also have my Docker Compose ready. Okay, so the files are safe on my system. Now let me execute these commands. Here, so it looks like Docker is installed. Now let me create the Docker file as I created it here. Uh-oh, looks like I closed the window. So no problem, I will open another one. So let's see if this build works. So it looks like this part is working. Looks like the CPU resources which we have given for Docker is too less. Perhaps we might want to increase that a little bit, but that will only take effect for the next deployment. So I'm just going to make that adjustment quickly. second thoughts, I feel the problem might be with memory and not exactly CPU. But anyways, since it's configurable, you can also experiment with the different CPU and memory resource limits, and just tell me what works best for you. Okay, so that's done. And if you see, the image has been built successfully. So this image is 987 MB in size. And now the next thing that we would want to verify is whether Docker Compose works. So what we are going to do is create a Docker Compose file based on what I created here, and then say Docker Compose build. As you can see, this seems to be working correctly. So that's that. We have our workspace set up. We have our Docker working correctly inside of this workspace setup. Now the last thing that's remaining is to create a Git repository. And of course, there's one more change before I do that. I have to push this image to Docker Hub. So let me do that quickly. So here, okay, so there's a little bit of disturbance. Just hold on, give me a couple of minutes. Yeah. So we're going to create a repository, salvapath.katl/code server. Code server, this is the repository. The code server with my customized code server coder.com/code server base. For cloud workspaces. I'm going to make this public. Create it now. Okay, so there seems to be some error, but let me assume that the authentication is successful and try to push. Okay, so there seems to be some problem authenticating with it. So what I'll do is, this is one problem which I'm going to fix at some other time. And yeah, so in the meantime, probably I could just make this repository available on GitHub so that you can play with it, experiment with it. There seems to be already one repository present here. I'll delete this and create a new one with a slightly different name. So here is the repository. So very soon I'm going to set up the readme.md and also investigate the problem that I'm getting with Docker login with Docker up. So these are the two things that I'll fix some other time. So thanks for watching.